What's up, guys? It is Tuesday, April 7th. Just want to start out today by basically outlining what the answers are on last night's exit ticket. So hopefully you finished that up, but I'm going to go ahead and list those out for you now. So number one, it said identify the outliers in the following data sets. So again, what you're looking for is the number, right, that's either extremely high or extremely low or much different than the other ones. So in this case, in part A, there is actually no outlier, because 21 is really close to 20 and 3 is really close to 4, and they're all relatively going up by 1 or more, right? So there's no outlier in that one. In part B, 12, 13, 14, 15, 16, but this one's all the way down to 101, so we're going to say that one's at 101. And then in part C, so this is actually the Fibonacci sequence, and the next number in the sequence would be 21, and the next one after that would be 34, and etc. But that's kind of irrelevant for this. So since 1 and 1 are so close together, 1 and 2, you could argue that 13 is an outlier because it is 5 away from the next one, whereas this one's 3. But as you can see, it's not really that far off. So I would argue that this is not necessarily an outlier. So this one actually also has none. Okay, for the graphs, identify the outliers in the following graphs. For number 1, it is 6. Part A, I'm sorry, for 2A is 6. For 2B, it looks to be -8 to -6. -8 to -6. And for the last one, the outlier is way up here. It looks like that's about 40. Okay. In the bottom, remember that when you are labeling the following graphs as skewed left, right, or symmetrical, it is skewed based on the direction of the tail. So since this one, the tail goes to the left, this is skewed left. Okay, this one actually looks like both of these are about the same distance, right? So we would call that symmetrical. And then on this one, the tail definitely goes to the right. So this would be skewed right. Okay? All right, so let's take a look at today's notes then. Today's notes, where did it go? Are the effects of outliers. So like how does it affect the mean, median, mode, and range that we've already talked about. So for the example that we're going to look at today, we're talking about the 2020 NBA dunk contest. And in this dunk contest, you'll see these are the list of judge scores from each contestant's dunk attempt. So as we look at this, there are a ton of 50s, right? 3, 4, 5, 6, 7, 8, 9, 10. And there are 1, 2, 3, 4, 5, 6, 16 total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And 16 total scores. So that tells you right there that our mode, which is the most frequent, is a 50. So ironically, it's a dunk contest, and yet the most frequent score is a 50 out of 50. Should tell you something. Anyways, to go on to the mean, remember the mean is the total of all of them added up by the number of times that it happened. So in this case, it'd be something over 16. So I've actually gone ahead and done this in Desmos already, just to save us a little bit of time here. So I added them all up, and that would be 776. Okay, if it'll let me zoom back in, which for some reason it's not. And it's frozen. Let's see if I can get this to come back. It's not. So I'm going to go ahead and write it in like this, I guess. Let's see if I close out of Notability, if it'll come back. Okay, let's try that again. There we go. Not sure why I was doing that. Let's see if I can now add in Desmos. Should be able to, right? There we go. I don't know what was happening there. Okay. And then with the median is always the middle number. Okay, so if we start crossing numbers off or listing them out, either way, but as you can see, the smallest number is 41. So let's cross off a 50. Next smallest is 45, so we cross off another 50. 46, cross off a 50. 47, cross off of 50, 48, cross off of 50, 49, cross off of 50. Now I have 4 numbers left, and they're all 50s. So what's our median? Our median in this case, the middle number is also a 50. And then our range, remember, is our biggest number minus our smallest. So this is going to be just 9. Okay. All right, so there seems to be an outlier. If we take out that score, what is the new mean, median, mode, and range? So just as you can see above, there does look like there is an actual outlier, like one that doesn't kind of go with the rest. And that number to me is 41, right? The rest of them are 45 and above. If you were to count those as test scores, those would all be A's except for one, that one B, right? So to me, that's an outlier. So let's take that out of our number. So if we have 776 and we take out that 41, see if I can go back up here for some reason. There we go. Okay, take out the 41. Now we have 735. 735 divided by 15 now, because there's only 15 numbers, is 49. Okay, now before there were 16 numbers, now there are 15 numbers. So once again, we're going to end up with a 50 in the middle. We can cross them all out again if you don't believe me, but when you go through the numbers, right, like the 41, cross it out, and there was a 50 up here that left a bunch of 50s in the middle. Well, if you cross that out, now there's still going to be that 50. It just moves to the right one. Okay, so new median is still 50. New mode is still 50. And a new range. New range. Okay, so now this is affected, right? Because it started at 50, and now our next lowest number is 45. So now our new range is affected by taking out that outlier. And our new range is only 5. Okay? So as you can see, like looking at the stuff above, you know, definitely affects some items more than others. All right, so let's look at the next thing. It says draw a box plot of the data with an outlier and a box plot of the data without the outlier. Okay, so a box plot, remember, has your mean, median, mode, lower quartile, and all those, right? So let's just go ahead and put that into Desmos. Let's list our data point. Oops, I don't want the absolute value. I want the brackets, which are down there. Okay, and 41, comma, 45, comma, 46, 47, 48, 49, and then the rest were all 50s. 2, 3, 4, 5, 6, 7, 8, 9, 9 and 10. Okay. Oh, no. There we go. Done. Okay. Now, remember, if you go into functions, you can click over into distribution, click box plot, label A. Okay. And height in 1, that's good. All right, and so now if we scroll over, you can see our box plot. Now, notice there is no top because we have so many that are there at 50. So we're going to go ahead and draw this. So it looks like it starts at 41, which is our low number. Goes all the way up to, let's see, where would that be? 46, 47 and a half, 47.5. Okay, and then 50 is our max, so it closes it out. Cool, all right. So now let's do this again, but let's take out our outlier. Now what does our box plot look like? Okay, so if we do that, now as you can see, it starts at 45 and then goes up to 48 and once again finishes with 50. Okay, so that's the box plot in this case. So as you can see, it definitely affects those things. So based on this information, which of the measures of center does an outlier affect most? Well, as you can see, the minimum's definitely affected, right? Well, what even more significantly is affected? We actually forgot to put this in up here. What is 776 divided by 16? I completely passed it up. My apologies. 48.5. So in this particular case, it didn't affect the median, it didn't affect the mode, but it definitely affected the mean and the range. So that's actually what it affects the most. It affects the mean, and even more specifically, the range. Okay? Okay, so then what is standard deviation? Well, standard deviation is another measure of the spread of data. It tells you how much a data set varies from the mean according to the top, right? And you can see, so the larger the standard deviation, the larger the spread of data. The smaller the standard deviation, the closer the data. So what do we mean by that? Well, if we're talking about, for instance, a test score, right? If the class average is, let's say, 75%, okay, and the standard deviation is 5. What that means is the average or the scores of everybody in the class generally will be within about 5 points of that, right? So it's not very big of a difference. Versus if I said the standard deviation of a class that had a class average of 75 was 15, okay, well now all of a sudden your class average is a 75, but you have scores that range anywhere from a 60 to a 90. Okay, so it's a much bigger spread of data, which means there could be higher and lower scores. It doesn't mean necessarily that there are or are not outliers. There can be in both cases. Typically, an outlier will affect the standard deviation in a way that we're about to take a look. So here's what we're going to do. Standard deviation is used to determine when data is normal and what data is extra large or extra small, right? So a big standard deviation tells you it's really big or really small data. But if it's a very small standard deviation, okay, well then that tells you it's probably all pretty close together. But you can use standard deviation to say this seems like a normal number, this is not, right? And therefore this is an outlier. So if we use that using our dunk contest scores, we're going to enter the information just like we already did, 41, comma, and the rest of those. Okay, and instead of now doing a box plot, we want to go back into functions, and you want to click standard deviation, which is under stats, but you want to click the one with a P. I'm not really sure why that is in Desmos. It's just the function that they use. Okay, so standard deviation with a P, and then type in your letter A. Okay, and that's going to tell you your standard deviation. So you can see the standard deviation with the outlier is 2.5. So what that means is, if you remember up at the top, we found a mean, right, of 48.5. So what that means is if I have a standard deviation of 2.5, okay, so if I subtract that and if I add it, so if I subtract it, then a normal score would be a 46.0, or if I add it, right, so it'd give you a 51. Like those would be normal scores, right? Anything outside of that is probably going to be an outlier, okay? That's what that means by standard deviation. Okay, so what is the standard deviation? Fill it in right down here. Standard deviation is 2.5. So give or take the scores fluctuate by 2.5. What is the mean? Well, we already set up there. It's 48.5. Okay, and what was the median? The median was 50. What if we remove the outlier? Remember that changed the mean. The mean went up to 49. The median stayed 50. But then the standard deviation, let's take out this 41 again. Now the standard deviation also changes, right? And it is now 1.63. So now, give or take, subtract that 1.63 and you're going to get a different number, right? So let's think about this. What if we increased every number by 5? Which values change, which values do not? Okay, so let's look at the mean. Let's look at the mean function, mean of A. Okay, it's 49. Let's say that instead of 45, we started changing all these numbers, right? So you have mean. That's without the outlier, by the way. median. Let's type that in just real quick. Okay. All right. So again, if I changed all these numbers and I added 5, so 50, 51, 52, 53, 54, and the rest of these are all 55s, right? Oh, of course that would happen. Let me just type them in. That'll be a little bit easier than having to go back. So A. Actually, no, that would not be easier. I forgot I have the back button. There we go. So I'm trying to get, there we go. I forgot the left and right arrows will change that. Okay, 55, 55, 55. Almost done. Okay. So when you replace all those, if you look, the standard deviation didn't change at all, right? That's because the difference, like standard deviation is talking about the difference between each number. So it's like how much you're adding and subtracting from each number. So it didn't change. If I change all of the numbers plus 5, that did not change. The mean changes. It definitely gets bigger. The median changes, right? So the standard deviation, and I'm going to abbreviate here, doesn't change at all. And that's important to know. So if you change every number, the standard deviation does not change. The mean, median, they do. Okay? What about range? Right? Think about the range. So if I increased all the numbers, it went from 50 to 55 was the new one, right? And the minimum, if without the outlier, of course, went from 45 to 50. Okay, so originally it was a change of 5, right? It's still a change of 5. So the range also does not change. Okay. Based on standard deviation, which scores were within the normal range? So the 1.63 is what we're going to look at, or I'm sorry, the standard deviation up above. We actually already talked about this. Okay, if you look up top, we said what are the scores that don't change? 46 to 51. So any scores 46 to 51 are within normal range. Based on this data, do you think the dunk contest has a good score system, or is it too easy to score well? That's a personal opinion. I think it's too easy. I think Aaron Gordon should have won, but that's my own personal opinion. Okay, is this data symmetrical or skewed? If it is skewed, in which direction? It is definitely skewed. There is an outlier that is pulling it left, right, because 41's low. So the data would look like this. So that is skewed left. Okay, so that's it for today. I know it was a little bit longer. I apologize. There's a lot to get in there. But you'll see your exit ticket at the bottom. And don't forget, tomorrow we will be working in class kick. As a class, so we'll jump on there at about 11 o'clock and we'll try and go through it together. So if you have any questions, Canvas message me, email me. Otherwise, I will talk to you guys.